Good morning. Good morning, everyone. Good morning and welcome to our webinar, Decarbonizing NYC Spring into Solar. My name is Justin Bulova. I am the Community Outreach Coordinator for NYC Accelerator. I am delighted to be moderating today's session, and I am very excited to welcome you all. Today, our expert panelists will delve into key topics, including the support NYC Accelerator offers for sustainable practices, the status and mechanics of solar energy in New York City, financial benefits of solar investments, federal tax credits for low-income communities, and navigating local zoning regulations to facilitate solar installations. Before we dive into today's presentation, allow me to give a brief overview of our agenda. We're going to get started just in a few moments with a brief program overview, followed by discussions on solar energy in New York City, how solar works, and the associated cost savings. We'll also cover the latest incentive updates and the City of Yes for Carbon Neutrality initiative. We will also save 15 minutes at the end of our session to address questions from the audience. Please use the Q&A function at the bottom of your screen to submit your questions for our solar experts. We're going to be holding all questions until the end. Today, we are honored to have two esteemed speakers with us, Daisy Rivera and Graham Van Korf, both solar specialists at New York City Accelerator. They bring a wealth of expertise and experience in solar energy, and we are very excited to hear their insights and guidance on decarbonizing New York City. Without further ado, I'll hand it over to Graham, who will begin with an overview on solar. Take it away, Graham.
Thanks, Justin, and good morning, everybody. Thanks for joining us for this workshop and webinar. My name is Graham Van Korf. I'm a solar specialist with the New York City Accelerator. I help all sorts of buildings find out if solar is a feasible investment, what it looks like, understand all the incentives. I've been doing so for the past year and a half. And I'll let my colleague Daisy quickly introduce herself as well.
Hi, good morning, everyone. My name is Daisy Rivera. I'm also a solar specialist with the New York City Accelerator and help buildings with cost-benefit analysis and reviewing all of the different tax incentives that the building may be eligible for and helping them acquire solar. I'll pass it back over to Graham.
Thanks, Daisy. Great. So we're going to talk a little bit about what solar is, how it works, and what the accelerator can provide for buildings that are interested in pursuing it. So first, a quick overview of what the New York City Accelerator is, and that is a program to help control costs, meet compliance requirements for local laws, boost building performance, increase energy savings, and reduce carbon emissions across New York City buildings. The New York City Accelerator provides free technical guidance to help the market transform how our buildings operate and are built. It helps identify building upgrade projects to meet emissions limits established under the Climate Mobilization Act and other local building energy laws. Offers no-cost building operator trainings and supports green workforce development, and connects building decision makers directly with service providers to implement decarbonization projects. And of course, it helps buildings identify applicable financial incentives and financing, such as the New York City Accelerator PACE. And so how does this program work? Maybe we should start off with who is eligible. So any privately owned building that is greater than 5,000 square feet, either new or existing, is able to take advantage of the New York City Accelerator's services. Smaller buildings, smaller than 5,000 square feet, can be referred to one of our partner organizations, such as the Center for New York City Neighborhoods. And really, you just give us a call or drop an email to get connected, and you're assigned a dedicated account manager for your property, and you can receive objective advice customized to your building's needs. And it is no cost, there's no catch, no sign-up commitment. Whenever you choose to participate in this program, it's purely on your own will. Great. So first, we're going to start talking about solar in the New York City markets, right? And how it's different here maybe than other places. Going solar because it's required. As part of the Solar Climate Mobilization Act introduced in 2019, buildings must have a green roof or solar energy project for all new buildings or major roof renovations. Solar is now a requirement as part of the law, and the New York City Accelerator program exists today to make this possible for all New Yorkers. And of course, for Local Law 97, in order to meet greenhouse gas emission standards, rooftop solar can really help lower a building's carbon emissions, and we'll talk about that shortly. As very kind of easily defined by this chart, you can see that the cost of solar over the past 10 or 15 years has greatly decreased. Solar is now more affordable than ever on its own, and also there are a number of incentives that help bring down the upfront costs and total costs of solar installations. Right now, it's more accessible than it has ever been. It's a great time to take advantage of it. And so I'll talk a bit about how the New York City Accelerator solar program can help buildings understand how solar will look for their unique circumstance. The New York City Accelerator program can help buildings understand what it will look like, what the associated costs and savings are, and how to take advantage of the multiple incentives to help make solar more affordable. Our solar feasibility assessment first includes a solar viability study to help understand, kind of money aside, does solar make sense for your building's roof configuration, zoning requirements, any shading issues? And then if it seems to be a good fit, we can conduct a full feasibility assessment, which includes a preliminary solar PV design, which is based on any building's given electrical consumption and roof configuration. So we ask for 12 months of your bills to understand exactly how much electricity your building has been using. And then with those designs, we pair a 25-year savings estimate. And it's a 25-year estimate because solar panels have an industry standard manufacturer's warranty of 25 years. So they are warranted for that period. They will, continue to work beyond that. But that's the kind of financial window where we look at payback period, upfront costs, utility savings, all available incentives. We paint this picture line by line to give you a detailed look of what this is going to cost you upfront, over time, the savings each year. And then once we've delivered that feasibility assessment, we can sit, your building representatives, property management, building owners, board members on a call and go through the feasibility line by line to make sure that all of the features of the estimate are understood and displayed accurately. And just to kind of reiterate, this is an estimate, right? This is a based on our experience working with over 800 buildings in New York City, what installers are going to, what choices they're going to make in terms of designs and how they're going to price those systems. And of course, you can access, if you're interested in moving forward with procuring solar, the New York City Accelerator helps connect you with service providers and find financing packages that make sense for your building. Well, aside from meeting local energy laws, solar is a key component to combat the negative impacts of climate change. Building emissions account for roughly 70% of all of New York City's greenhouse gas emissions, and the importance of solar on buildings in New York City cannot be understated. Solar will ease the reliance on New York City's old and constrained grid, reduce energy burden for low-income New Yorkers through solar savings, and ultimately lead to more green jobs in the city. So now I'm going to talk a bit about kind of the mechanics of solar, how it works, what the pieces are. There are 3 types of installations in New York City. And by that, I don't mean 3 types of panels. There's 3 types of ways that the system interacts with the roof, right? So how it interacts with the roof deck, the roof membrane, how it's kind of affixed onto the roof of the building. And so you'll see any one of these 3 across New York City's rooftops. I'll start on the left with a ballasted array. A ballasted array is a very low profile installation method. It requires little to no actual penetrations into the roof deck. They are held down with generally cinder blocks, and everything is weight load and wind load tested. So just because they're not, affixed into the actual roof deck does not mean that they're going to, go flying away. And these are, of the 3, the least expensive installation method option. They're really great if you have if you have a building that's less than 10 stories, that has a pretty large roof, and you don't feel very space constrained. These are an amazing option because they are easier to install. Again, you don't need to penetrate the actual roof deck, but they do have a little bit of a spacing between each of the modules, as you can kind of see, because they're tilted and you can't shade them. You don't want one panel to shade another. So if you have a lot of space and you don't mind, having a little spacing between the panels, and you can still offset a majority or all of your building's common area emissions, these are a really, really great option to start with. Then if we'll move to the planar array, otherwise known as a mechanically attached array. These are much better for a space-constrained roof. As you can see, all of the panels are directly touching, lined up with one another. There's no spacing in between them, so you can really maximize all of the solar potential and usable space for the roof. But these are also integrated into the actual roof deck, so you can see the flashing beneath the panels. And because of the additional engineering work and construction work for these, they're a little bit more expensive than the ballasted option. And that leads us to the canopy array, which maybe you can see. Sometimes you can see these, when you're walking, at the street level, looking up at buildings. For this installation method, the panels themselves are raised usually 9 to 12 feet above the roof deck, held up by, larger structural component, sometimes steel, that raises it right over the head. And so this has a lot of benefits, one of which is that it is not subject to the same DOB, Department of Buildings, and FDNY clear path requirements that require 6 feet clear path across multiple points of the roof. So you can really cover the maximum area of the roof if you need to, and still allow for the roof to be used. So if you are, if you have a recreational area on your roof, if you have HVAC equipment, condenser units, other things you might be storing on your roof, you can build the panels right over them and really maintain that access. Of course, this is the most expensive of the three, just because, again, of the much more in-depth engineering and construction work that goes into them. And not a single one of these is better than the other. It really just depends on your roof's configuration and what your goals are for solar, how much your building consumes electricity, and how much of that consumption you want to offset with your own solar production. And deciding between these three installation methods is something that our solar specialists help you do. We can sometimes present multiple designs with multiple outcomes, different pricing, just to give you an example of what all of your options are. And this is a very kind of simplified slide about how solar works, a very kind of 101 about what the pieces are. And I'll just walk you through it really quickly. So you can see on your roof, you have your solar panels, and these are working as long as there is sunlight out. There's no on or off switch, no moving parts, little to no maintenance. And as long as there's sun, they are turning that sunlight into DC, direct current electricity, which is fed from the panels through conduit, which is that kind of green line you can see on the screen, down into the inverter. And the inverter is usually located in the electrical room. Sometimes it's located on the roof as well. And the inverter has two parts, two components. The first of which is that it turns that direct current electricity into alternating current electricity, which is what our appliances use in our building. So that creates a usable form of electricity. And now inverters act as monitoring devices, so they can hook up to your building's Wi-Fi or use a cell card, and it will give you real-time production of your system down to panel by panel. And installers will give access to the building super or your board or property manager, so that you can monitor in real time what your solar production is. And you can see if there are any potential issues, right? If one panel or row of panels is underproducing, that might be a reason to contact your installer and have them come out to see what's going on. From the inverter, it's connected directly to your regular common area meter. And that meter is simultaneously tracking both the buildings, how much energy the building is pulling from the Con Edison grid, and how much solar production the building is using. And it sort of works like an old car. And I'm thinking of like Ferris Bueller's Day Off, but a successful version where if you drive the car in reverse, the odometer goes back the other way. So that's how this interconnection works. As you're using electricity from the grid, your count of kilowatt hours goes up. As you produce electricity, it goes down. And then whatever, at the end of your billing period, whatever the remaining amount is, the difference between whatever you pull from Con Edison to what you're producing, is what's billed on your Con Edison account, and that's called net metering, the difference between the two. And this is, and most rooftop solar in New York City, a vast majority of it is what's called grid tied. So it is still connected to the larger Con Edison grid. And any excess electricity is sent back to the grid in exchange for future credits on your common area or whatever account you're hooked up to. In the summer, let's say you have a solar system that's sized just about to exactly what your building is consuming. Because solar is somewhat seasonal, in the summer, you might overproduce slightly, more than 100% of your building's needs, and that excess would go back to Con Edison, and they keep track of it on your bill. And then in the winter, when you're underproducing, you can pull from that bank of credits to help offset the remaining portion of your bill. So the savings are year-round, even if the same level of sunlight is not the same in June as it is in December. And this is called the net metering configuration for buildings. So speaking a bit more about how the savings appear on your bill, a major, we'll talk later about the incentives that are available for solar in terms of bringing down the upfront costs. But the really important and main kind of payback for these systems is the savings on your utility bills. And those savings can vary based on a few different variables. One of which is the electricity rate, the class of electricity tariff that you are in for Con Edison. And there are a few different ones. There's residential, large commercial, small commercial, master metered, and each one has their own rate by which they're purchasing electricity from Con Edison. For large commercial buildings, which are otherwise known as EL9, they're paying slightly less per kilowatt hour for electricity from Con Edison, usually about what we're seeing is 15 or 16 cents. As opposed to small commercial, EL2s, maybe that's like a walk-up building, a small residential building. They're paying usually 30 to 32 cents a kilowatt hour from Con Edison. And because solar is directly offsetting those kilowatt hours, 1 kilowatt hour of solar for a large commercial building is technically worth less upfront than it is for a small commercial building, where it's worth 32 cents, right? Because you're replacing that kilowatt hour from Con Edison. And these are all the things that we will look at your bills and help you sift through to understand what your utility savings are and how to maximize those savings with the system on your roof. And of course, what also greatly matters is what's called the solar interconnection method. And that's sort of what I was just talking about with my Solar 101 diagram that I was showing you. But there are, a couple of ways to integrate with the grid, right? So net metered, it hooks up directly to your existing common area meter, and it feeds directly to the building. Excess goes to the grid. There is another form of solar interconnection called CDG, or community distributed generation, in which case you have solar on your roof, and that is not connected to any existing meter in your building. A new meter called an export meter is installed, and all of the electricity on your roof is fed directly to the grid, which allows for multiple accounts to be offset by credits from Con Edison for that electricity produced. So right in that first example, you're just offsetting usually your common area because that's the largest account. But in a CDG, or sometimes community solar, on-site community solar, it's referred to as, let's say you have more than enough space on your roof to offset more than your common area and enough to even benefit the residents in your building. Let's say you're in a co-op and you want all of the shareholders to have some direct utility savings on their bill. Depending on the size of your roof, you could install a system that feeds directly to Con Edison, and Con Edison will distribute monetary credits to all of the accounts associated with that system. So the common area account, and then all of the residential accounts in the building. And again, deciding between these two configurations for interconnection is something that our team has plenty of expertise on, and understanding what the benefits and detriments are to each decision. And we can come up with multiple arrangements to help you understand what those associated costs might be. Now, what makes a building viable for solar? And some of this can feel, some of the answers to this are pretty simple, which is sunlight exposure. You need a lot of sun in order to create enough electricity to really, give you the utility savings you need to pay off the investment for these systems. So you need a roof that has direct sunlight, really minimal shading, and that could be shading from trees, shading from a nearby building, shading from obstructions on top of your building, such as a water tower or HVAC equipment. Obviously, more room on your roof is great as well, so that you can really maximize the system, maybe even use a ballasted system, which again is slightly less expensive than a planar or a canopy system. And of course, a large roof will allow you to, still have a large system while taking into consideration the various fire paths and clear paths needed by the Department of Buildings and the fire department. And lastly, solar is always best paired with a new roof or a roof that has a very long life ahead of it. As I mentioned earlier, solar panels have a 25-year manufacturer's warranty. And so you can expect them on your roof for at least that amount of time. And if you have to, do a major roof renovation halfway through, 10 years into the lifespan of your panels, and have to take apart, have someone come out, take apart those panels, reinstall them, that's an added cost that could, negatively affect the return on your investment for these panels. So we usually recommend that as you're thinking about solar, you're thinking about your roof, and as you're thinking about your roof, you're thinking about solar with any, renovation plans that you might have in the future. And I will pass it on to Daisy to talk about how to bring down the cost of your solar installation. Thank you so much.
Hi, everyone. Thank you so much, Graham. If we can head over to the next slide. Great. So I'm going to be talking about the different cost savings associated with solar. So on this slide, we have a table that reviews various different incentives that are available to different building types. So if we go down column by column, these are the different incentives that are available. And then across, you'll see each of the different rows represent different building types. So the easiest way to read this table is just based on like each of the squares and the different colors. Now, if a building is eligible for a particular incentive that is listed there, you'll see that the square is highlighted in a darker teal color. And if you're looking at the lighter teal color, light blue, light teal color, then this building may be eligible for this particular tax incentive. There's a specific circumstance or whatnot that may be not allowing it to like fully reap that benefit, but it may be eligible for that incentive. And if we're looking at the darker gray squares, then this specific incentive is not applicable to that specific building entity. It's overall a very overwhelming table to look at, but I do want to point out that incentive levels are subject to change based on the building type, and our team of solar specialists are here to help you understand which of these different incentives are eligible to your specific building type. If we could go to the next, thank you. So as I referenced in the last table, the first incentive that was listed is NYSERDA's NY Sun incentive, which is essentially a rebate that is available to all building types in New York City. So essentially, this is a rebate that is paid directly to the installer, and its entire purpose is to help bring down the upfront cost of the solar system to the building owner. So the NY Sun incentive, excuse me, the NY Sun incentive essentially can help cover anywhere from like 20 to 40% of the total cost of the system itself. So again, incentive levels are subject to change, and they're based on the application and contract signing to lock in those incentive rates. If we can go on to the next slide. So this slide basically covers how you can actually save money with solar with like visual representation. So typically a lot of the projects that we work with are multifamily buildings within New York City. And they typically have a payback period of an average of anywhere from 5 to 12-year payback period. So if we are looking at the first graph to the left, you will see that a project that will have an estimated of a 4-year payback period. And that's with solar tax incentives taken into consideration. Now, if that building, for whatever reason, does not take any of those tax incentives into consideration, then you will see in the graph on the right that the estimated payback period is pushed back to 8 years. So it's just a quick comparison to see that how solar tax incentives do make a difference in terms of providing savings to buildings. And I should mention, Graham touched on this a little bit, but it's represented over a 25-year period just because the solar panels are typically warranted for 25 years. And if we could go to the next slide. So in the next section, I'm briefly going to be talking about the different ITC low income bonus tax credits that are available to buildings. Next slide. So there are various different bonus tax credits, bonus adders that are available to certain solar projects within the city. So these bonus adders can be stacked on top of the 30% base ITC tax credit. So if you see the table on the little graph on the right, that dark teal color is your base 30% ITC tax credit. And then each of the other green color squares are representative of all of these possible bonus adders that are available. So we're going with the lighter colors. So there is either a 10% or a 20% low income bonus adder. So this is dependent on either the building's location, the affordable rental housing status, as well as, I'm sorry, or the type of solar project. So it's important to note that these cannot be stacked on top of one another. So it's either you're taking the 10% low income communities bonus adder or the 20% low income residential building project or the 20% qualified low income economic benefit. I will touch more on these specific credits in the next few slides. And if we're moving down the line, can you go back? So on if a project is eligible for a project could potentially also be eligible for the 10% domestic content bonus adder. And in order to claim eligibility, essentially the project materials that are being utilized for a solar project has to be made of 100% domestic steel and iron, as well as these project materials have to be manufactured or sourced within the US. And another option in terms of like bonus adders is the 10% energy community bonus. Now, if a project is located within an energy community, then they would be eligible for this 10% bonus adder. So this would include brownfield sites or a building or a project that is within close proximity to like coal or gas mine facilities. And overall, these are all stackable. In the best case scenario, if a project were to meet all of these different eligibility requirements, then there is a possibility to receive a maximum of like 70 of the 70 tax credit benefit. But I should point out that in general, majority of the projects that we see will be eligible for the 30% ITC-based tax credit. But again, our team is here to help you decipher and see which other bonus adders your project may be eligible for. And next slide, please. So specifically referring to the lighter blue squares that I was referring to on the last slide, the 10% low income bonus adder, which is the low income community adder, is based on the project's location. So if the project is located within a census tract, it would be eligible for this credit. So the way to basically determine this is by using the low income communities bonus credit map. And you'll be able to designate if it falls within one of those census tracts. So I should also point out that there is a preference for net metered projects and for projects for entities that are nonprofit organizations or for projects that are located within persistent poverty counties. So typically there is a 1-month window application period per program year, and applications are typically accepted on a rolling basis if the allocation does not fill up within that 1-month initial application window. So because this specific category for this 10% bonus added credit was over subsidized last year, it will likely only be available to that specific project if they meet the additional qualification criteria, like it being a net metered project, or if it's a nonprofit organization, or if the project is located within a persistent poverty county. Next slide, please. So within the low income communities bonus credit program, there is an opportunity to get a 20% low income bonus adder. So this one is based on the affordable renting housing status of the building and how its benefits are distributed to its residents. So this can be done by either having those credits from the energy savings be directly sent over to their electricity bills, or by distributing a portion of those financial benefits into a residential benefit. So there are various different residential benefits, and you can refer to HUD's list of applicable benefits to determine which would be applicable. And so you'd meet this specific criteria. So this process typically requires submitting to pre-apply for this credit and then receiving a capacity allocation and then placing the facility into service. Next slide, please. I also want to point out that we will be I also want to point out that we will be sharing a recording of this, and there are some resources and links within each of the slides. So you can refer back to if you need to access the map that I was talking about, and then just some frequently asked questions, and all other resources will be listed within each of the slides as well. So on this slide, we're going to be talking about elective pay and transferability. So essentially, there are two distinct options that are available for entities that are not directly eligible to take advantage of the 30% base ITC credit. So we're looking on the left. The first option is referred to as elective pay, which is also commonly referred to as direct pay. So this one is applicable to your entity if you are a tax exempt organization. So that can include nonprofit organizations, as well as local governments. So you would be able to take advantage of this credit through the direct pay option. So in order to receive this credit, the owner would need to pre-file and register to receive a direct payment after filing their initial tax return, after the system has been installed. The second option on the right now is the transferability option. So this option is available to entities that are not an elective pay entity. So this could, for example, be developers or cooperative buildings. So for this option, the entity can choose to transfer all or a portion of the tax credit to an either unrelated taxpayer in exchange for cash payments. So I do want to point out that this is still a developing part of the market, and we are continuously learning and reviewing how this process essentially continues to work. And Next question. Next slide, please. So in this last section of the presentation, I am going to be reviewing the City of Yes zoning regulations. Next slide. So roughly a little more than 6 months ago now, the City Council voted to pass the City of Yes for Carbon Neutrality initiative, which essentially aims to decarbonize New York City. And it's working on updating, and I'm sorry, it already passed. So it helps with these zoning changes. It allows for it to align with different climate goals, as well as reducing building emission reductions by a goal of the year 2050. Next slide, please. So on this slide, I'm going to be talking about what does this mean for your solar project? Like, what are the major changes that are associated specifically with solar? So the first change is that it removes coverage and setback requirements for solar canopies on flat roofs. So solar canopy systems, as Graham defined, they're raised up off of the ground of the roof. So these can now be designed up to 15 feet in height, regardless of the zoning district. So in regards to specific like canopy installations, previously we were limited to designing systems up to only cover 25% of the roof coverage in certain zones. So now we are no longer limited to that. So we are able to design past that 25% limit. And the second change that you can see is that it now provides greater flexibility for solar on pitched roofs by expanding an allowance from 18 inches to 60 inches, which ultimately allows for greater tilt of the system, and it allows for to maximize solar capacity, essentially. The third change is that it allows solar canopies to cover parking areas in every district by classifying them as permitted obstructions. So previously, there were some conflicts that prevented canopies over some parking lots, and that eliminates that barrier, and they're now permitted obstructions. So we could have more carports, canopies over parking lots. And the fourth change is that it now permits standalone solar. So for example, larger community solar arrays, it permits standalone solar up to 10,000 square feet in residential zoning districts. So previously, these larger community solar arrays were classified as commercial use, and they were not permitted within certain zoning districts, and specifically residential zoning districts. So now that they are considered, now that they are allowing standalone solar within residential districts, and they won't require any sort of special approval. And the last change is in regards to energy storage systems. So now energy storage systems up to 10,000 square feet are permitted within residential districts, as well as commercial and manufacturing districts. So again, energy storage is a bit of a tricky subject, but they still must conform to DOB and FDNY requirements within any zoning district. And next slide. And that wraps up our presentation for today. I will pass it back over to Justin for Q&A. Thank you.
Excellent, excellent. Thank you so much, Daisy. Thank you, Graham. That was an exceptional presentation. It was super informative. I want to remind everybody that if there was any part of the webinar that you missed or you weren't able to catch, a recording will be made available. It won't be made available right away, so you can log into YouTube and subscribe to our channel. You'll receive a notification once that is available. We will also be circulating the slides for your resources and for further use. At this time, we're going to be opening up the panel discussion to Q&A. If you haven't already submitted a question through the Q&A function at the bottom of your screen, now is your time to do so. Please do let us know if there's any pressing questions or hot button issues you'd like to cover. Some of the topics might be a bit reiterative, but I think it's important that we reiterate some of these key points and make sure that we cover all the addressed questions. So first question here, this one is going to be addressed to Graham. Graham, how does installing rooftop solar support other electrification projects such as heat pumps?
Find my mute button. That's a great question. So obviously, buildings are electrifying left and right, and a lot of those electrification projects, such as heat pumps, such as electric boilers, domestic hot water, can increase the electrical load and demand of any given building. And solar is a great pairing for those projects because you can offset the additional electrical costs that you might have for installing heat pumps with the solar on your roof. And you can do that retroactively. You can do that at the same time you're considering these projects. Right? Any electricity that would be captured on the same meter that solar is offsetting, you can offset those costs with a design. When you're working with the accelerator and our solar specialists, I mentioned that we look at your historical electrical usage for your building in order to accurately size the system. But if you're currently considering any or have plans for any electrification projects that might increase the demands on your building, we can wrap those estimated, demands into the same analysis and give you a look at, okay, well, here's what it would look like, based on as is right now, just with the current, electrical demand that you have. And here's what it would look like if you also are pairing solar with these other electrification projects. Of course, it depends on, how those projects are captured by the meter and the size of them. But it's a great way to really offset those demands by really creating your own electricity, right? So thank you, Justin.
Yeah, excellent. Thank you, Graham. That sounds like there's really a holistic approach to this, and maybe there's a lot of different components that our solar specialists can help you navigate. Excellent. Well, next question I have here from an anonymous attendee says that electricity use in common areas may be minimal compared to what a large solar installation is producing. Is it true that the excess is credited by Con Edison at very low rates? I'm not sure which one of you wants to take that.
I can take that one. So if you are configured with, as I mentioned earlier, the net metering configuration, right, where it's hooked up to one account, excess credits are kept, you're offsetting kilowatt hours at a one-to-one basis. So whatever you are paying for a kilowatt hour of electricity, when you produce a kilowatt hour of electricity, you get that level of savings. And the credits for that system are the exact same. So if you were overproducing, let's say by 100 credits, 100 kilowatt hours, sorry, you have 100 credits of 100, 1 kilowatt hour per in your bank to pull on in future cases, future billing cycles. That being said, for net metering for that system, we don't usually recommend oversizing quite a bit, because if you're already offsetting your bill, over 100%, then those excess credits are kind of redundant. So you really want to keep the system size to right about 100% of your building's consumption, so that you don't have kind of excess credits, excess energy produced that's kind of just sitting in a bank somewhere, not being used. But then, if you have, this is kind of to our earlier point, if you have a much, much larger roof than what you can offset with just common area charges, that's when you can begin to explore those on-site community solar, right? So offset, sending it all to the grid and then just distributing credits across multiple accounts. Obviously, each situation is fairly unique, and so we would just recommend reaching out to the accelerator with your exact case, and we can help paint a picture for what it would look like.
Excellent. Thank you, Graham. I think this next question is for Daisy. Daisy, Jonathan Cooper is asking, he says that, does the Con Edison credit apply to supply charges and the much higher often delivery charges?
Yes. Hi, Jonathan. Thank you for your question. So it essentially depends on the building's electricity tariff. So tariffs is basically a way that Con Edison determines and distinguishes different building types and within which specific area of New York City you may be in. You may be in an area where there is a higher demand during specific times throughout the day. So if you do happen to be like, they're categorized like EL1, EL2, EL8, EL9. I believe there's EL11 as well. So it's all dependent on that. And a larger building, which would typically be categorized as an EL9, would not cover those. So only the supply and not the delivery charge is just based on that this building has a greater demand on it. So it would help offset just those, but that's with the net energy metering interconnection. If you were to opt for a CDG interconnection, which Graham touched on, which is known as community distributed generation, it would allow for you to cover for the solar energy system if it were able to produce enough energy to offset both of those charges on your electricity bill.
Excellent. Thank you, Daisy. Thank you. Great. We have a question here from Barbara. Barbara is saying, our roof is owned by the penthouse. Are there other solar options for the building other than the roof? Are there solar farms in New York City that are available to for us to use as an alternative? Graham, I'll let you take that one.
Sure. That is a great question and something that we didn't touch on exactly during this presentation. But if you, again, you can always reach out to us to talk about this more. So I'll give a kind of brief synopsis of this. Yeah, what happens if your roof isn't viable, right? Like what if you don't have the space for solar, you have shading on your roof, or maybe you don't even control the roof of your building, right? If you're a renter in New York City and you can't control, what goes on your roof, or if it's owned by the penthouse, right? There are programs called community solar, which is kind of, as you mentioned, a solar farm, like a large solar system set up somewhere in New York City that is feeding electricity directly into the grid. You can subscribe to these solar systems, these community solar farms, to receive a credit from Con Edison on your bill to get some bill savings. Usually we see about 10% savings, but there's no cost to sign up. You can access these community solar developments online, and they, again, there's no cost. It's free savings. It's just more clean energy into the grid. I will say about community solar, right now there is more demand for these projects than there is supply. Community solar is kind of tougher in the New York City area because we're talking about a much larger system that needs to be set up, and there just is very limited space. And so we're working, solar installers and developers are working very hard to try to find sites that can host large solar projects. But there are, community solar dashboards such as Power Market, where you can see available projects in New York City and see if you're applicable. And if you have more questions about this, I'm happy to connect offline sometime and talk to you about what those options are. But it's a great way to access solar energy, even if you don't have a solar ready roof or control your roof.
Excellent. Thank you, Graham. Thanks for that. I think I'd like to cover landmark buildings and landmark historical neighborhoods a little bit. I'm seeing a lot of questions in the Q&A coming in on this subject. Here's one in particular. Graham, maybe you could tell us a little bit about the changes in the City of Yes canopy restrictions and other measures that apply to landmark buildings and landmark historic neighborhoods.
Sure. So, and I'll also let Daisy, if there's anything I can fill in, please jump in. But generally, historically for landmarked buildings or buildings in historic districts, solar is considered a permitted obstruction, but it needs to be like quote unquote minimally visible from the street, right? And that's already a relatively kind of subjective quota requirements. So it just means that you can't really see the system if you were to walk, from it at any point, like in front of the building. And so generally, buildings that are landmarked or in historic districts will install. You absolutely can install solar. You just need the kind of more low-lying systems. But I saw a question, I think, in the chat about canopies in landmark districts and if they're allowed. And the answer is yes. And again, they just can't be visible from the street. So if you have a roof that maybe has, kind of goes to the back of the building, we've helped buildings install, that are in historic districts, install canopies in the back of the building, maximize that area. It's not visible from the street. And then in the front of the building, you can do kind of like a mixed system, right? Where you have some of it's canopy, some of it's either planar or ballasted. And of course, it depends on the configuration of your building. but it just can't be fully visible from the street. So there's lots of ways to go about it. And again, for any of these circumstances where it's kind of a gray line, I absolutely recommend reaching out to the accelerator, and we can give you a detailed view of, you know, what's really possible for your roof given all of these restrictions.
Excellent. Thank you, Graham. Thank you. Just wanted to also touch base. I know that the webinar is going to be ending at 11 a.m. Anybody who submitted their question, if we do not get to it, we will try to follow up with you immediately after the webinar. Please allow us a day or two to get to your question. You can also reach out to us via the information on the screen, as well as the information that I dropped in the chat. Okay, great. Well, I think we have a few more questions here in the Q&A. I think we'd love to cover a little bit about the different types of solar installations again, if we have a moment. Daisy, would you mind jumping in and telling us a little bit about reiterating the different types of solar installations?
Yeah, so there are, I think Graham is going to pull it up for us, but there are 3 types of different solar and types of installations. So the first is typically a ballasted installation. So this essentially requires little to minimal penetration in the roof membrane, and they're held down by cinder blocks. And they're a better option for like rooftops that are larger, just because they're held down by cinder blocks. So there's spacing in between each of the different rows. And then the next 2 options are planar and canopy options. So these do require integration into the roof membrane itself. So these do allow for a lot more solar capacity, so a larger system in like tighter constrained space. And as we talked about, canopies are raised up to anywhere 9 to 15 feet off of the ground. So they can cover a lot more of the roof area space if you're looking to maximize solar.
Excellent. Thank you for covering that. Appreciate it. I know we had a few questions on that. And I had one more question here from Christopher. He was asking, can you tell us a little bit about how the current demand compares to the available number of suppliers and installers?
All right, Chris, I'm assuming maybe you were asking about the community solar projects I was just mentioning. In that circumstance, it's hard to say. Some projects, different community solar projects might target like a different audience. So some are looking exclusively for subscribers that are low to moderate income or in disadvantaged communities or certain census tracts. Some are just kind of more open generally. Some are open to buildings, some are not. Like building accounts, you can hook up to community solar, some are not. It just depends on the specific project, but there are like services, and we can connect offline if you'd like to, that help you kind of figure out what's still available and what you're applicable to. But I will say it's the kind of thing where right now for community solar that there's some patience needed to get onto a project, just because there's some unlimited demand supply.
Absolutely, that makes a lot of sense, Graham. I think that's a nice segue into our next question from Serge. He had mentioned that there's a lifespan, there's maintenance of solar panels, and can you tell us a little bit about that life cycle and the maintenance, and what recommendations that you have based on your experience?
I'll take this one since Graham just answered the previous one. So solar panels are so self-efficient. They require little to no maintenance. Thankfully, we don't live like in a windy, dusty state where they get dirty. There are services out there that you can pay for, and that's totally up to the building owner's preference. But whenever it rains, it just washes right off because they're designed and a specific tilt, so it will completely melt off, and they're designed in a particular way in which they are in direct they're in the direct line of the sun, so it will self-maintain. And then I think that was all for that question. Graham, anything else?
Yeah, just to add, right, yeah, like exactly as Daisy said, there really isn't much in the way of maintenance for your system. Installers can sometimes offer separate like O&M, operations and maintenance packages. which it will be like outside of the costs of the system itself, where they come by, once or twice a year and do a checkup of the system, cleaning. But generally speaking, for at least multifamily buildings, residential buildings, we aren't seeing that much of a need or appetite for those packages. But they certainly do exist, and that's something, if you were engaging with installers, that you can ask about, what kind of maintenance do they offer and what's required of you. But generally very little. It's the best thing is to be hooked up to the dashboard to look at your production so you can see what's going on with your system.
Yeah, that makes a lot of sense, Graham. And I think we talked a little bit about the post-installation maintenance, but I don't know how much we dove into the solar installation process and the timeline. Could we maybe step back a moment, and could you walk us through the typical timeline and the steps involved in the solar installation process from initial consultation to final activation?
I'll let Daisy take this one.
Okay. So timeline. So typically you'd be working with us, our team of solar specialists. We specifically assist buildings with pre-installation, pre-construction services. So we would prepare a cost-benefit analysis essentially for your building to determine which incentives are available and whether it makes sense to go solar, whether it is financially a financially economic option for the building itself to pursue. And then in terms of actual installation, the next step would be signing a contract with a solar installer. We do not handle the solar installation itself. We handle just consultation pre-development services. And then from the point of signing the contract with the installer, essentially that can typically take anywhere from like a week or two, just depending on the owner's preferences and the installer as well. And then they handle all of the paperwork, the permitting, the application, submitting all of that to DOB, to Con Edison. If it's a landmark building, they handle all of that paperwork on your behalf. And that can take anywhere from like 6 to 8 months, general timeline. And the physical installation of the solar system can be anywhere from like 1 to 2 weeks. So that's typically like one of the quickest process in this whole thing. The most lengthiest process is just the paperwork, submissions, and approvals.
Excellent. Anything to add there, Graham? No. All
No,
right,
just
excellent.
just that it takes a while, and if you were to sign a contract tomorrow with an installer, you probably wouldn't be looking at a finished installation between 6 to 12 months from now. So, which also, if you're thinking about other electrification projects or roof work, it gives you time to kind of complete those projects while the solar is in motion.
Excellent. Excellent. Well, we just have a couple minutes left. So again, I apologize if we're not going to get to your question during our session today, but our solar experts are going to work with us to make sure we get to all of your questions as quickly as possible. Wanted to quickly cover some concerns, some overlapping concerns that I'm seeing in the Q&A. Some folks are raising concerns about hurricanes or inclement weather. Some folks are raising concerns about who might be liable for damages in the event that this kind of work were to fly off. And some folks are talking a little bit about how would you shut off the panels if you had to give access to 911 emergency services such as FDNY, if they needed access to the roof. Could you talk a little bit about some of these kind of incidental outcomes and incidental situations?
Yeah, I can start, and Daisy, feel free to jump in. So I think I want to just step back quickly and say that, right, any installation method, so between ballasted, planar, and canopy, is all wind load and weight load tested. So that's up to, I believe, 110 or 120 mile-per-hour winds, up to DOB code. And so for the storms that we're generally seeing, it's not they're tested for those things. Ballasted systems are only allowed on buildings lower than 100 feet for that exact reason, because the wind tends to be stronger as you go up higher. So in that circumstance, you might want something that's actually affixed to the roof. But that being said, every installer, right, I mentioned the industry standard, like manufacturer's warranty for the panels themselves, for the equipment, for the modules. But installers, of course, have their own workmanship warranty. And that usually is at least 5 years, sometimes 7 or 10, or much more than that, depending on the installer. where, if anything comes up that's due to their installation in that period, so a roof leak, right, like 2 years after the system is installed, they are responsible and liable for coming back and fixing the damage from their system. Hope that answers your question.
Excellent. Yeah, thank you so much. Daisy, anything you'd like to add there?
No, Graham pretty much covered it. Thanks.
Excellent. Excellent. I
Oh,
know yeah, go
one more
ahead.
thing. Sorry and the installers will work with your roofer or your roofing contractor to make sure that any roof warranties are not voided during the installation. So they'll communicate where they need to. And there was a question that asking if some installers do roof work, and yes, some of them do. It can range depending on the scope of work that they're able to do. Right, some can only do smaller patchwork, some can do full coating, etc. So it's best to kind of ask your installer what their approach is. And obviously, if you're thinking about solar, we recommend getting as many proposals and bids as possible just to compare.
Yeah, I think that's really great advice. Thank you, Graham. Well, we are at 11:01, so we are officially concluding this webinar. I wanted to once again thank you all for joining us today for this webinar, Decarbonizing NYC, Spring into Solar. I hope that you all use the link in the chat or the contact us form that we shared briefly to get in touch with either Graham, Daisy, or myself to address your unique situation, your unique building. We will be going through the questions and trying to get back to you as soon as possible. A recording will be made available through our YouTube channel. And once again, I encourage you all to get in touch and connect with us to work on some projects. Thank you again. Thank you for joining us, and we hope to see you again soon.